Good evening, everyone. Today, in this mission 99 of Space Analog Mission Habitat Marte, we are going virtually this year, and we are going to talk about sustainability on space habitats. In during this complete mission, this was a particular theme, and for today, I'm going to present a launch center. What will be the complete model of launch center if we are going to, set up a habitat over the Mars. So there are some kind of requirements based on the basis of design, on the basis of management, some of the protocols which are to be followed. So that there will be a comfortable and smooth functioning of a complete space habitat with the launch activities. So in during this presentation, I'll be talking about all these. I'll be covering all these main topics. So I am Paras Adlakha, and currently I'm pursuing BTech Aerospace Engineering from University of Petroleum and Energy Studies, Dehradun. And this is my third time participating in Space Analog Mission Habitat Marte in Mission 99. Earlier, I was a part of Mission 52 and Mission 54, where I was a chief of engineering center and a power station in the latter one. So here I'll be covering the launch center today. So I think we can now just start the launch. So these are some of the topics I'll be covering during this my presentation, and there are some of the topics like, as I already mentioned, I'll be talking about the design, and then I'll be talking about some of the technologies, then what are the resources required for in situ activities, then what will be the organizational structure, positions, and all these things. So starting with the external 2D design of our module of our space habitat. This was I guess this was a schema designed by one of our earlier colleague in a mission 47 by if I remember, Yash Rathod, and he designed this 2D and 3D model where we can see how all these modules are connected to each other. The launch center is directly connected to the main center, because a launch center is one of the important facility which is to be stay connected with main center, so that in case of any urgent or emergency or a requirement, they can directly contact to the main standard, with the mission commander can give some of the do some of the discussions and give some of the orders to follow up and remove the need of urgency. And after that, we can also we can see that there is a sanitization center, then there is a moxie, then a power station, then 1 kilo of nuclear power in this habitat Marte. Then there is a greenhouse facility and a health facility, and power station is equipped with a solar farm where it will be running with the help of nuclear power as well as a solar power. Here also we can see that this is a 3D module of the same 2D schema, and this was also proposed by Yash Rathod in Mission 47, where we can see the launch center at one of the at the left side of this screen, and in the screen we can also see how this complete habitat Marte will look like after once set up on the Martian environment. Now, from here, I'll be talking about the internal design and some of the technologies which can be indulged in the our hybrid Marte launch center, so that it can have a functioning in regard. Talking about the internal design, there are some of the specific needs and method to be followed. So to demonstrate the suitability of the launch site location for launching at least one type of launch vehicle, including orbital, guided suborbital, or unguided suborbital expendable launch vehicles, and reusable launch vehicles. Each proposed launch point on a launch site must be evaluated for each type of launch vehicle, such that mission requires to have launched from a launch point. So, in case when we are going to set up of our habitat Marte on a Martian environment, so we have to take in mind the launch point, what are the fruitful launch points for us, so that we can set the satellite or our rocket in a suborbital, orbital, or a reusable launch vehicles, from where we can launch all these vehicles at a particular point. So we have to remember in mind, like we have to find out such kind of launch points to set up our habitat Marte, and or at that point our launch center will be situated. And mission commander is provided with a choice of methods to develop a flight corridor for a representative launch of an orbital or guided suborbital expendable launch vehicle, or to develop a set of impact dispersion areas for representative launch of an unguided suborbital expendable launch vehicles. So while talking about all these design requirements of our launch vehicle, when we take in mind the geographical characteristics and the landscape and the location, so all these data and the content I have taken is from a very what I can say, one of the recognized organization of USA, the FAA, and actually these are some of the requirements which are used today on Earth while we are designing a commercialized space center or a launch center. So these are some of the requirements, some of the safety and some of the requirements while designing space center on Earth. So some of the rules are regulated by federal government as well as of FAA. Now coming to the first floor of our launch center, we can see this is a 3D printed center, where we can see there is a in between a EC LSS system and a data and communication system. There is a washroom, and there is a gallery where from where we can enter the data and communication center. And also there is a cultivation area, so that there would be vegetation and all these things. And there are stairs to move on to the second floor and third floor. The second floor will be where the person will be sitting around, and there will be a complete unpacking and packing of the goods and resources which are to be sent to the space, or which are coming from a space, and also assistant researcher and the uh, chief of the launch center will be working on those floors. And apart from that, there will be HVAC systems, and on third floor there will be dormitories and washrooms and other facilities to move on to the day to day need basis. So coming to some of the applied technologies, while talking about some of the applied technology which can be which I already mentioned, like there will be a HVAC systems for heating and ventilating air conditioning, and I also mentioned environmental control and life support systems, and support technologies for data collection and recycling practices. A good communication and navigation system will help us by giving the data about nearby storm from satellite in Martian orbit. Because of some distance, there is a substantial delay in a data transfer. So for the deep space mission, a good quality of antennas are required. The necessary tools are also required for the maintenance of rockets and the launch center, and also some of the tools or some of the goods and resources to help or support other modules of the habitat Marte. And there is one of the protocycle technology which I learned about in a mission 54. The protocycle technology is nothing. It's just a 3D printer. It just a material provided for a 3D printer. And in this, what we can use the waste already collected for from daily basis, and we can put that protocycler put that waste into a protocycler as a fuel, and it will give us the 3D the material for the 3D printing. So this is some of the technologies which we can indulge in our launch center. And there will be battery backup for rover related activities, because on a Martian environment, the rovers are if we talk about for current scenario, the rovers are the only means of providing the data, and what we can say, the the landscape, how the landscape is working. So these are some of the activities which will we can do with the help of rover. And also in a current scenario, we are taking a good data from Perseverance and some of the earlier rover missions of Mars. While talking about the launch vehicles have some so far there are different launch vehicle. While talking about the launch vehicle, they have included traditional orbital launch vehicles such as Atlas, Titan, and Delta, as well as suborbital vehicles such as Starfire. New vehicles using traditional launch techniques include Lockheed Martin Corporation's Atlas 3 and Athena, EERS Conestoga, Orbital Sciences Corporation's Taurus, and the Boeing company's Delta 3. Now talking about the some of the unique vehicles such as Orbital's Pegasus and Zenit 3 SL of Sea Launch Limited Partnership, launched from a modified all rig located in Pacific Ocean, are included in some of these launch vehicles counts. New launch vehicles are proposed every year, and I'll be talking about some of the latest launch vehicles in a next slide. On the horizon, there are some of the currently Lockheed Martin's Atlas V is used, and a number of companies are proposing partially and fully reusable launch vehicles. In addition, some companies are participating in partnership with NASA to develop X-33 and X-34 launch vehicles incorporating reusable and single stage to orbit technology, a partnership which could result in a launch vehicles for commercial use in a coming future. And while talking about some of these launch vehicles, there is we are already aware about the company SpaceX. And so coming to SpaceX idea of Martian single stage to orbit, and there is a rocket named Starship. They are working since 2016, and they have already done some of the modifications in it. Earlier there was a 12-meter diameter carbon fiber interplanetary transport system, which can be seen in a figure 1. And after that, a 9-meter diameter carbon fiber Big Falcon rocket, which can be seen at number 2. And then there was 9 diameter carbon fiber Tintin style Big Falcon rocket in September 28. So till September 28, the third figure was the modification done in the Starship. And coming to the fourth one, it is a 9-diameter stainless steel Tintin style Starship till December 2018. And after that, the finally 9-meter diameter stainless steel Starship in September 2019. And for this model, they have done many testing. They have done testing of many models so far, talking about SN8, SN9, and on 5th of May 2020, uh, uh, coming this year, they are going to test positively. They are going to test SN15 or SN20, and they have already come up with the last launch was a successful one, and they have also Particularly, this is a first stage of rocket, and the second stage is a booster stage. And particularly, they are also side by side testing the booster stage as well. And initially, they have stacked both booster stage and first stage of a rocket with ceramic tiles all over, to check how it will particularly look, and how, to how much extent it will look in a 3D model. And also for that, they're also preparing the launch pad, which is unique in its own. And it will be having hanging bars, which will where this launch where this is our launch vehicle is going to hang over the launch pad. So coming to the management side of the launch center. So apart from astronaut, there will be a launch chief, there will be a assistant and a researcher, and also a technicians which are required for the launch center. The researcher, assistant, technician, and chief all must come from background related in science and technology, such as data science, mechanical engineering, astronaut, aerospace engineering, propulsion engineering, and they can come from any background, if we say, because there is when we are talking about the science and technology background, they can come from many apart from different domains, because a data science, a mechanical engineer, a aerospace engineer, then coming to a systems engineer, then MCC, and all these kind of persons are required while talking about the launch center. So now I'll be talking some of the management and some of the responsibilities of these persons. While talking about the launch center chief, he'll be responsible for studying how the in situ practices are going on. He will also be responsible for how the launch vehicles are prepared, how the testing is done, and how the launches are going on, and from where the module is coming from, where it will to be going on. And he apart from that, he will be also monitoring each and every section of the engineering center, because at first floor of the launch center, there will be a small engineering center where they will be doing some of the center related things. There will be a workshop, there will be a rover maintenance, etc. So he is a person to be connected directly from earth, as well as other facilities in case of an engineering requirement. And also, while talking about, he will be also a kind of a manager for a launch vehicle. Now coming about to the assistant, he will work under chief and is responsible for stock management. Also can be contacted in case of tools or equipment required. Then apart from that, there'll be a researcher, or what we can say in these categories, in the category of researcher, the astronauts, the systems engineer, the data science engineers, and mechanical engineers will also come. While talking about the technicians, so these are some of the person coming from a background where who will be taking care of the 3D printing and communications and maintenance, and antennas, and some of the things which are to be handled regularly, like some of the walls of the launch vehicle, and some of while talking about the propellants, and all these things will be taken care by these technicians. So all these person will come in the category of technicians. So coming to the astronaut training program, so the basic training will be provided with the first floor, where we can say the engineering center of the launch center is also there. So there are I come up with this idea because we are having a particular engineering center in our Habitat Marte, but we have to take care of engineering related activities in our launch center as well. So because we cannot go and run and take help for everything from engineering center, because engineering center will be doing its work on a daily basis, and the launch center is also has also is also having a requirement some of the engineering related activities. So a small engineering center will also be there. And if there arises a situation where um some of the big emergency or urgency comes, so we they can directly go and take help from the engineering center peoples as well. So uh, while working, keep in mind the sustainable use of space, habitat, as well as the resources. The training related to dust removals system should be given to each and every astronaut member. Support long term effect of isolation, capabilities to handle the architecture and technologies for human exploration. Protocols while having launch should also be taken care of. Different rules based on safety requirements of a launch vehicle will also will be coming in under this training program. So, so far I have by doing some of the calculation, when we are talking about only 4 persons when kept in a launch center, we know that there is a requirement of more than 4 persons. But while talking about if we have taken 4 persons in our launch center, then the daily consumption will be around 200 kilocalorie per person, and weekly consumption will be around 1400 calorie per person. And a water of 3 liter per person will be required, and weekly consumption will be 4 liters. And coming to some of the guidelines to be provided to other facilities. So the basic guidelines should be followed by other facilities while using the communication as well as the 3D printing product required by them, which are already placed in a launch center. And regular research and development activities between the facilities are required for the successful completion of the mission. Regular meetings are required between the chief of the facilities to run the mission smoothly without any problem. Now coming to some of the protocols which are to be followed in launch center. These are initially there will be a specific protocol routine of the facility. Regular obstacle determination to avoid damage. Regular rocket inspection. The machines like rover and 3D printer should be not be overloaded during the use. Regular temperature and other wall checks for propellants. The spacesuit must be dried off dust each time the astronaut go out for Mars work. The data reports should be maintained and back up regularly. Now, coming to the protocols of safety, the guideline request for an applicant to provide the information regarding geographic characteristics, flight paths and impact areas, and the meteorological environment. Also, to describe a launch site geographic characteristics, an applicant who is forming a mission is requested to provide information regarding the launch site, location, size and shape, its topographic and geographical characteristics, its proximity to areas, and any local activities that may be infected by the launches of a habitat Marte. An applicant also provides the plan, possible flight paths and general impact areas designated for launch. Here, in place of applicant, we can think about any person who is taking the charge of a launch, like the launch chief, and if there is anything required by other launch other chief members of the habitat Marte, like if something is required by the power station, which is to be transported from the earth, then he's an applicant who will go to the launch center chief and ask for an flight to have a backup for the power station. So if land flight corridors overfly land, and the um, guidelines requires that an applicant provide flight safety analysis for generic sets of launch vehicles and describe where applicable any arrangement made to clear the land of people prior to the launch vehicle flight. Here, the people is used in place of the astronauts who are already moving around the habitat Marte. So these are some of the safety protocols to be followed while having a launch, which is scheduled by the launch center chief or any other center chief if required. So protocol for occupancy and entertainment for a launch center, regular social gatherings to reduce the stress, smooth music inside the space habitat will reduce the chances of depression during the isolation. The activities and cultivation in social areas can be organized. Uh, Protocols for food micro production. The food logistics must be checked regularly and calculated. The waste management system should be made in order to recycle it. The risk management is also necessary to avoid extra losses of food items. Protocols for 3D printing, the regular check of material for manufacturing, the protocycle and 3D printers must be maintained as per the requirement. The system should be not be overloaded. Some of the spin-offs of a launch center coming where guidelines to be applied to daily life on Earth. Waste management activities should be practiced regularly. Where we are talking about the waste of the propellants as well as on Earth we use fuel and while on Habitat Marte Launch Center uh, there are different types of waste like the human waste, the other waste from launch center as well as the propellant related waste and all these things to be care of. The investment in research today will give a result as the comfort and betterment of tomorrow. To sustain life, new technology and development in industrial field is required. So coming to the impacts to sustainable development goals, initiative to be taken care of while talking about the economic growth, reduce, we should reduce, reuse, and recycle propaganda. The launch center will be working on this propaganda, the reuse, reduce, and recycle. That's why when we are talking about the launch vehicles, we can go with the Starship because it's a completely reusable booster as well as the first stage of the rocket. Development of system that use less energy. And when we're talking about the launch vehicle, the Starship so far calculated is the cheapest means is going to be the cheapest means of transportation to the orbit. And waste material recovery facility is also will also come under the sustainable development goals of the launch center. So these are some of the references, and also I have mentioned some of the references below some of the slides which are used while preparing this PPT for the launch center and doing some research. And here are my social media details for LinkedIn, Instagram, and Twitter. And now I'm open for the question and answers round.